Hey networkers, so to visually prove what a host is and why routers and switches are different, I want to show you host, that is devices that sends and receive user data. Then I also want to show you network devices, that is devices that forward traffic. So in this packet tracer lab, I want to build a small topology so I can show you what this is all about. So let's build a very small network to understand what a host really is. Okay, so let's go. Here have PC1, a PC here and another PC there. Then I have a server. Then I'm going to bring network devices, that is my switch 2960. Then I'll bring my router 2911 router. So I'm going to connect it everything together. So you connect your PC to your switch using a straight through cable. Okay, so connect your PCs to your switch using a straight through cable, and you connect your switch to your router using a straight through cable also. Then you connect your router to your server using a straight through cable also. So this is a small topology. We're going to really work on it and learn something new, something important. I'm coming. Just give me a minute. I like to set up my topology very well. Okay, so we are going to assign IP addresses to these devices. Okay, so I know you guys will be wondering, why don't I connect the pieces to the router? Okay, let me just explain that. It's because hosts connect to switches and switches connect to routers. That is how the standard setup works. So now I will need to assign IP addresses to the devices. Okay, so I give this one a static IP address 192.168.1.1. Let's give it 10. Okay, so I'll need to assign a default gateway to it. This is /24 network. As you can see, the subnet mask, that is how you know what network this IP address is. Okay, so we're going to assign an IP address to default gateway to this PC. So 192.168.1.1, that will be the default gateway. That is the first usable IP address. So the second PC, they'll be in the same network. So we're going to give this 192.168.1.11. I don't know what that was. 192.168.1.11. That is the /24 network also. So we are going to assign the default gateway 192.168.1.11 dot one. What is the default gateway? Dot one. They're in the same network. Okay, so they use the same gateway. So we've given the PC's IP addresses and subnet mask and a default gateway. Okay, so now we need to configure the server. So we're going to give it a static IP address also. Oh, assign it the default gateway. That is 192.168.2.1. Okay. Um, this is okay. Let's give it the IP address 192.168.0.10. So this is on different network, different subnet, but still uses /24 network, but it's on different subnets. Okay, so the interface is on, so since it's connected to the router. All right, so you're seeing red there because the router interface is off. So by the time I configure it, it will come up and the line will show green like this. So what are we going to do next? We've assigned IP addresses to hosts, and these IP addresses we assign to them, they'll use it to be able to identify each other and be able to communicate, right? So they also have their default gateway. That is how they send traffic that are going outside the network. Like if the traffic is going outside this network, that is this IP address, this subnet. Um, here we have 1.11, and here we have 2.10. That means this one is on different subnets, that is different network. So yes, that is why they need a default gateway. Otherwise, they won't be able to communicate with this network here. That is the server. So please take note of that. So yeah, we'll now need to configure the router. You say, would you like to enter the initial configuration dialog? We say no, and we enter and go to enable privilege exec mode. Then go to configuration terminal, conf t. So we are here now, we need to do our configurations. So let me check the interface of this. G01, G00. So we'll do interface int G01, and we give it its IP address 192.168. That's the default gateway we gave to the server, remember. So it's gonna be 2.1, because if you can remember, that is what I gave to the server, its default gateway. I'm coming. So 2.1, so we're going to give it 2.1. That is the /24 network. As you can see, it's 245, sorry about that, /24 network, that is 245.255.255.0. So that is what we are going to do. We are going to give it the subnet mask 255 192.255.255.0. So you do no shutdown to enable the interface. I'm using no shut. So we're going to go to the interface G00. There is this interface. As you can see, this interface is it's up now. I told you by the time I enable it, it's gonna come up. So let's enable this one also. So after interface, we give it IP address 192.168.1.1. Am I correct? I should be. So .1.1. This is the default gateway. That's what we are going to give to this. Um, then the subnet mask, as usual, is /24. So it's 255.255.255.0. And you click enter, then you enable the interface with no shutdown. I'm using no shut. So we're going to end the configuration, go back to privilege exec mode using end. You can also use control Z, and go back to privilege exec mode. So yeah, we are done with that configuration and the interface is coming up. This is going to take 30 seconds. 30 seconds for this to turn green because of spanning tree. So the interface that connects the different networks together, it's acting like a user, right? So it's what this interface does is to forward traffic. All right, it's to forward traffic between these hosts. These are hosts, these are end devices. So the router interfaces, its role is to forward traffic between these hosts. So notice that I didn't assign an IP address to the switch. So the switch is forwarding the frames at layer 2. If you remember the OSI layer, the switch is forwarding frames at layer 2. So it doesn't need an IP address to do its job. Alright. So its main job is to forward traffic within a LAN. So the important thing here is switches can also have an IP address, okay, but the IP addresses are mainly for management, but they don't add that. We don't need to add it here. All right, we don't need to add IP address here because we don't want to manage the switch. So it's okay like this as it is. So let's test connectivity between the devices. All right, so we're going to ping from this PC3 to this server. So do you guys think they'll be able to communicate or they won't communicate? What do you think? um I don't know. I think they should be able to communicate. So we're going to ping 192.168.2. What is this IP address again? 2.10. All right. Excuse me, please. I need to take this off. Okay. 2.10. So, moments of truth. Okay. So, ping is successful. So, we'll need to try to ping. We need to ping from server to PC2 or to PC1. Okay. So, remember that without the router, these these networks they won't be able to ping. They wouldn't have been able to ping without the router. Okay. So the router is forwarding traffic. So let's ping 192.168.1.11. That is PC2, and it should ping because of the default gateway. So we have a ping. So these devices they can communicate because they are hosts. Okay, that is why they can communicate, and they send and receive data directly, as you can see. So yeah, the thing is, I've heard this definition so many times, and it finally clicked for me. Okay, it finally clicked for me that in networking, any device that is connected to a network and participate directly in communication is called a host. All right, and the key word here is participate. So these PCs, the servers, they are all hosts because they send data, they receive data, and they have IP addresses. All right, and now the router and the switch, they can have IP addresses. As you can see, we gave the router an IP address, right? They can have IP addresses too. That is correct, because I know some of you might be wondering that what about switches and routers that have an IP address that can be assigned an IP address? Are they also known as hosts? I understand they can have IP addresses, but they are not hosts, right? They are not. So these are hosts. These end devices, they are called hosts. So routers and switches, their role is different from hosts. Okay, they actually act as, they don't act as end users like end devices, right? Or their role is to move traffic from and exchange, control information. So information can communication can happen within these end devices here. So the moment I understood this whole concept that I just showed you in this lab, networking started to make a lot of sense to me more, and I hope it makes sense to you also. So we're going to do another video very soon. For now, bye.